It is the main purpose of designing this process. And initial investment is high. Naturally, initial investment is high. And for that purpose, so far we don't have any plasma arc furnace in India, whereas people are having these furnaces for the last 30-40 years running successfully in South Africa. I myself have seen one plasma arc furnace 36 MVA running very successfully. And in all forms, I try to, tell the people we should go for other routes also, so that in long run we can have advantage. This is the plasma technology. Just flow sheet electrical diagram. Here, the furnace shell in the bottom will act as a anode, and electrode is a cathode. And this is the, all reactors are in the circuit. This is just for your understanding. This is the electrical circuit of the plasma arc. And this is also what plasma arc technology details: furnace and electrode, and how other people are producing in this route plasma arc technology. And preheating of raw materials. Like I told you, all the raw materials are preheated in the day bins. In the rainy season, I have seen even in ferroalloys, all the raw materials are stacked in outside yards, and a lot of moisture, 10%, 15% moisture is there. But we have no other alternative of drying the materials. We feed it to the furnace, and then there is chance of having eruptions. There is chance of specific power going high. In spite of all this, we are running in the same way. But South African people, they developed Tenova Pyramid, that is the company. They developed drying technology. In the day bin itself, before entering to the furnace, all the raw materials will be dried to the moisture level of 1% maximum. So that they are proposing to Indian producers also. It is under discussion in India now to adopt that technology. Advantage is achieving less specific power. At least 10% you will get less specific power, and briquettes can be fed as an ore, and overall productivity increases. In all the process,
2 more minutes.
Yes. Whatever I discussed, this advantage, 10%, 20% cost of reduction will be there. This is DAMA technology. This is having separate tap holes for slag and metal like blast furnace. In ferroalloys, most of you may be knowing, we are taking out metal and slag through only one tap hole, and after tapping we will separate metal and slag. But in Albania, they are producing, having different heights tap holes, taking out both slag and metal, and they are having better separation. Refractory lining is also a little bit different for this, tapping metal and slag at different timings, and savings minimum 10% of present variable cost. This Albania expert contacted me, and he told if any Indian plant is willing to adopt this, I will show minimum 10% of the cost of reduction what you are incurring now. And we are dealing with Tatas, and even Vedanta and Jindal Stainless. With all those people, this process is also under discussion. As an experienced person in this route, this is the DAMA technology process what they are adopting in Albania. Different tap holes at different heights, like blast furnace, they are tapping the material. So as an experienced person, I am trying in India, coming from the old routes, why can't we go for new other routes, economical routes, which other parts of the world is adopting, so that our cost of production will be minimum, and it will be an encouraging for the growth of the ferroalloy industry and for the growth of the country. So finally, I urge all Indian ferrochrome industry should seriously think about above mentioned techniques, should venture with the high initial investments for long-term gains. Yes, we have to venture when we have to get something. It is the only way to withstand international market turbidity, which is very much high in the case of ferroalloys. Thank you very much. Thank you.
Thank you so much. So the session is open for question and answer. Any questions?
I have one question. Since you have vast experience in, you are associated with this industry.